Have you ever been writing a SQL query that just felt clumsy? Like you were trying to build a ship in a bottle? It's super complicated, messy, and you're just one wrong move away from the whole thing falling apart? Well, today, we're going to talk about the tool that smashes that bottle: SQL window functions. Seriously, they are the secret to writing cleaner, faster, and just incredibly powerful queries. And trust me, they're not nearly as scary as they sound.
You know, if you've ever been deep in the weeds on a complex query and someone casually asks you this, you know that feeling, right? It's like you've missed some secret handshake. Well, today is the day. Consider this your official invitation to the club. We're about to demystify that secret and show you exactly what they mean.
So why do window functions even exist in the first place? Well, they were basically born out of a really common frustration, a wall that pretty much every data person hits when they're working with traditional SQL.
Okay, here's the core issue. Think about standard aggregate functions like sum or AVG. When you use them with a group by clause, what happens? They collapse all your individual rows into a single summary row. And that's great if you just want totals. But what if you want to see an individual sale and compare it to, say, the regional average, all in the same result? Standard SQL makes that incredibly painful to do.
The old school ways of getting around this are, let's be honest, a total mess. You'd have to use things like correlated subqueries or self-joins, and these aren't just a nightmare to write and read, they can be terribly inefficient. They often lead to something called quadratic complexity, which is a fancy way of saying that for every new row you add, the query gets exponentially slower. It can literally grind your database to a halt.
And this is exactly where window functions come into play. They give us an elegant, powerful way to just sidestep all that complexity and solve the problem directly.
This is the concept right here. A window function lets each row look at the other rows in its group, almost like it's looking through a window, to perform a calculation. But here's the key. It does all of this without losing its own place in line. It preserves the individual row, but it gives it context from all its neighbors.
So what's the secret sauce? It's this one simple keyword, over. When you add the over clause after a function, you're basically telling SQL, hey, don't you dare collapse these rows. Instead, I want you to perform this calculation over a specific window of data. It's the magic ingredient that turns a normal aggregate into a powerhouse window function.
And the benefits? They're huge. You end up with code that's just way more readable. You get this incredible flexibility to mix and match row-level details with your aggregates. And a lot of the time, you get a massive performance boost because the database is literally built to handle these kinds of calculations efficiently.
Okay, so how do we actually control this window? The real power of that over clause comes from three key components that let you define exactly what group of rows you want your function to look at.
Let's break this down. First, partition by acts like a set of dividers. It splits your data into independent groups, or partitions. Think of them as separate buckets. Then, within each of those buckets, order by arranges the rows in a specific sequence. And finally, the frame. This is where you get really precise. Defines the exact subset of rows within that partition you want to work with. Maybe it's the 3 rows before the current one, or maybe it's the entire bucket. This is what gives you that surgical control over your calculations.
All right, that's enough of the theory. What does this stuff let you actually do? Let's look at a couple of powerful, real-world examples where these functions are absolute game changers.
One of the most common things you need to do is create rankings. You know, top-selling products, highest-scoring players, whatever. SQL gives us 3 fantastic functions just for this job.
This table shows the difference perfectly. So look, row number just gives every single row a unique number, even when scores are tied, like with Alice and Bob. Now rank is a little smarter. It handles the tie by giving them both rank 1, but then look what happens. It skips rank 2 and jumps straight to 3. But dense rank is often exactly what you want. It also handles the tie, but it doesn't leave a gap. It moves right on to rank 2. This is absolutely perfect for leaderboards.
Okay, another amazing use case is what I like to call time traveling through your data. By using the lead-an and lag functions, you can actually compare a row to the rows that come directly before or after it.
The lag function lets you do just that. Glance into the past. It pulls a value from a previous row in your ordered set. This is incredibly useful for calculating things like month-over-month growth or seeing the change in a stock price from one day to the next.
And lead does the exact opposite. It lets you peek into the future, grabbing a value from a following row. This is awesome for seeing what happened next, or maybe forecasting inventory needs, or analyzing how user engagement changes over time.
So what all this really leads to is a pretty crucial realization. Mastering window functions isn't just about memorizing some syntax. It's really about fundamentally changing how you think about and approach your data problems.
This quote absolutely nails it. You stop thinking about each row in total isolation, and you start thinking about its context, its frame of reference. You're no longer just looking at a single data point. You're asking, how does this sale compare to all the others in its region? Or what was the value for this specific user yesterday? That shift in perspective is what unlocks the real analytical power here.
When you start combining partitioning, ordering, and framing, you unlock this incredible ability to solve really complex problems with code that is both elegant and efficient. So the real question isn't if you should use window functions, it's what's the first problem you're going to solve with this new way of thinking?